Welcome all to this lecture. In this lecture, we are going to discuss about the second normal form. So, the first normal form we have already discussed. So, we know what is the basic rule in the first normal form. So, we are going to learn about the second normal form. So, in case of the second normal form, there are two basic rules that are available. The first rule is the table must be in the first normal form. So, whatever table or relation that we are going to have, it must be, first of all, it should satisfy the first normal form. Now, if we try to recall what is there in the first normal form, so the rule was we should not have multi-valued attributes under any circumstances. Okay, for example, if we are going to have let's say value under city. Okay, so for one particular person, if the customer is belonging from two different cities, or if the customer is registered from two different cities, so under the city there should not be two different values. So there are three different approaches also we have discussed. In the first approach we have discussed like if we can have the multiple columns, or sorry, if we are going to increase the number of rows keeping the customer id as similar, or you can say duplicate. But by that, what we are going to face, if we consider customer id as the primary key, so the duplicate value will be there. So that approach is not good. And if we consider the second approach, so we can have two different city value in two different column, let's say city 1 and city 2, that is by adding multiple columns. But that approach is also not good in when we try to design a very good like database table. So we are not sure whenever the data are increasing, and based on that data we cannot go and increase the number of column. So the third approach was splitting the table so that each of the table should contain some primary key or some key attribute which can uniquely identify the value, and the city value should be like different in different under different rows. Okay, so that was there in the first normal form. So when we are going to discuss about this second normal form, we are going to have this first rule, that is the table or the relation must be in the first normal form, and the important part, that is the second rule. Okay, so we need to understand this particular part carefully and logically, so that we are going to implement this. Okay, so what this second rule says, that all the non-prime attributes should be fully functional dependent on the candidate key. Okay, or in other word, in some other references, okay, it may be written that there should not be any partial dependency. Okay, there should not be there should not be any partial dependency. This is another way of representing this second normal form. Okay, now let's try to understand about what is this non-prime attribute. Okay, what is this fully functional dependent, what is this candidate key. Okay, so in our previous discussion we have discussed something about at like types of attribute. Now attribute, when we talk about this attribute can be divided into two parts. One is prime attribute, or the other one is non-prime attribute. Okay, so what is this prime attribute? Any attribute which participate in identifying the number of records uniquely is called as the prime attribute. For example, the primary key or the candidate key, or you can say the composite key, those things are called as the prime attribute. Okay, so if you consider this particular table, so customer id, or you can say the store id, these are the prime attribute, and this particular city can be termed as the non-prime attribute. Okay, so I hope this part will be clear. What are the basic difference between prime and non-prime attributes? then what is basically this fully functional dependency? Okay, this part. So from here we have to implement that logic of functional dependency. If you remember, in case of functional dependency, we represent with this x tends to y. Okay, so we have to use this particular logic of x tends to y. And one more part has been given over here is the candidate key. Okay, so first of all we need to identify the candidate key. So with every table you will be getting the information about what is the candidate key or the composite key or those sort of like information. Okay, so let's say first of all we'll note the candidate key. So in this case we are going to note the candidate keys are as customer ID as well as store ID. So these are the candidate key. So from this candidate key information we can easily identify which are the prime attributes over here and which are the non-prime attributes. So let's identify the prime attributes. Prime attributes here are the customer ID and store ID. And non-prime attributes are basically the city. Okay, so what this particular sentence is saying, this particular statement is saying that whatever non-prime attributes, which is the non-prime attribute, that is the city, whatever the non-prime attribute in a particular relation, okay, that exists, it should be fully functional dependent on the candidate key. Which are the candidate key, or which is the candidate key in our case? So customer ID and store ID are my prime attributes. Together it will form the candidate key. Okay, so these are my candidate key, so we are going to have the functional dependency should be in this way: customer ID comma store ID should be fully functional dependent on, city will be fully functional dependent on customer ID as well as store ID. The meaning from this particular statement should be like that. Now we need to check this one. Okay, I am going to erase all this and we are going to check this particular table whether it is fully, like whether it is following the second normal form or not. Okay, so as per my logic what we have derived just now, customer ID and store ID is determining city. Okay, now we are going to check this functional dependency with the data that is available over here. Okay, now we see this is the value for the first record, customer ID 1, store ID 1. Okay, and Guwahati is the city. So let's consider 1,1 Guwahati. Okay, and if you consider the second one, 1,2 is Kolkata. Okay, 2,3 is Delhi. Okay, next one is 3,2 is Kolkata, and so on. Now if you look at the combination of 1 and 2, this is column 1, this is column 2, this is column 3, or you can say different attributes. Okay, if you take the combination of these values, whether it is determining Guwahati completely or not. If you consider this value, if it is determining Kolkata properly or not. Okay, but from here we can identify that it is not always the participation of the customer ID is making the difference. Okay, the point is, if you look at the values, like this is Guwahati, this particular record Guwahati, when it is Guwahati, the store ID is 1. Once again, when it is Guwahati, the store ID is 1. Okay, and here the value is 1 and the value is 3. So that means this particular column Guwahati is basically getting dependent on the store ID rather than the customer ID. Okay, you try to look at some other data. Let's say this data, that is Kolkata. Okay, Kolkata, whenever the value Kolkata is appearing, you see the store ID is represented as 2. Here also it is getting as Kolkata, the store ID is 2. Here also the city name is Kolkata, the store ID is 2. And you check the customer IDs, in this case it is 1, 3, 4, it is not changing. So from this sort of thing, we are coming to a conclusion that the logic that we have written, that is customer ID and the store ID, is not determining city properly. Okay, so this part is not at all correct in this example. So which means the functional dependency that we have followed, or that we have derived over here, it is not following the second normal form. Now what is the solution to get to the second normal form? Okay, so in the previous case also, and in the earlier examples also, we have come, like we were discussing about splitting is one such way. So that splitting we are going to discuss. Okay, so if we, okay, before that, if we can draw the table directly over here. Okay, so if we can derive something, if we can divide the table in such a way that whatever the key prime non-prime attribute and the relationship between prime and non-prime attribute, it should be fully functional dependent. Based on this particular logic, if we can derive something, so let's say we are making one table. Okay, just a second. Okay, let me show over here. So here if you see, this is our actual table. Okay, so what we have done, we have just splitted the table into two different table. In one table we are keeping customer ID and store ID, and in the other table we have store ID and city. Okay, now we need to be very much sure that we are not supposed to lose any data from the existing table after the decomposition. Okay, so here we are going to check the rule for the second normal form. What was the rule? That whatever the non-prime attribute, it should be fully functional dependent on the prime attribute. Okay, so if you consider this particular table, which is the non-prime attribute, there is no non-prime attribute. These all are prime attribute, so that rule doesn't applicable over here. Okay, and what is the if we implement the rule in the second table, city is definitely a non-prime attribute. Okay, and this city is actually getting dependent on store ID in this case. Now is it satisfying the rule for the second normal form? If you consider store ID 1, it is giving you Guwahati, 2 it is giving you Kolkata, 3 it is giving you Delhi. All are unique. So that means whenever the store ID values are changing, your city is also changing. Okay, so this particular table, or you can consider both the table, are now in second normal form. Okay, So this is about the second normal form. Thank you.